Okay, so the purpose of this searching and sorting, we're going to be learning how, like, some algorithms on how to search for some kind of value in a list or in an array, or like in two different ways. There are many different searching algorithms, but we're going to be looking at two of them: linear search and binary search. And then later on we're going to be talking about different type of sorting. Well, how to sort information. There are different types of sorting, and then we're going to be seeing again bubble sort and selection sort. And we'll do some exercises, and there's some online tools that we're going to be using, because they're going to be allowing us to visualize those sorting and searching. So let's start with that. Now I'm going to use this website over here. I have the link there, and this website basically just gives you this. Now this is just a website that is going to show you, but maybe this is going to be a better view. Like, if you're going to be if this is an array that you have, see, this is an array of, how many elements do we have in that array?
16.
Or this is the first part of the array, this is the second part. This is like an array. These are the indices, which means from 0 to 31, that means we have 32 elements in that array. And then notice one thing though, this array here is, the values are kind of special, because can't you see something interesting about those values? They are increasing. The array is sorted. Now, well, if I'd like to, maybe, what is that? This is the width and height. Maybe I can just change the height to be 400. Can I change that? Change to 4. Can I? No, can't. Okay, so I'd like to go for a linear search, but the problem is I just wanted to, okay, no, just a small one. I just would like to, when you search, you need to put the value that you're looking for. You're just searching for that value to see if it is somewhere. However, this I wanted to see if we can just have something that is not sorted, like any random number, but it doesn't seem to give me that option. Move controls, well, no. Well, that's okay, fine. So I can have this here. I wanted to, here you can change the animation speed, how fast it goes when things are put. For example, if I'm looking for the number 5, can I? Why? What is the problem? It doesn't seem to be allowing me to. Okay. All right. Let's say I'm looking for this number, and I'm doing a linear search. Now, this shows you that, I mean, it gives you some kind of a code, or like pseudocode, or maybe some kind of code. I don't know what kind of. I mean, this is probably another programming language. This is not Java, by the way. This is I think this is Python. It's not C++. I think this is Python or any other. I don't know exactly what kind of programming language it is. I think probably it is Python, if I'm not sure. Def, linear search, and then you can still understand these things. I mean, you can have an idea about what it is. This seems to be a method, and these are some parameters. List data and then value. List of data, probably this is the array, and then the value is the element that I'm looking for. Let's say this 5. Now, if based on this type of array, this is why I wanted to have some kind of a more random data. But the idea is that, let's say if I'm looking for a number, whatever that number is, the linear search does this. Just always starts from the first one and checks if it just looks if the number that I'm looking for is at the position, and it keeps going from 1 to 1 until it reaches the end of the array. And now if it finds it, let's go faster. Okay, if it does not find it, means it was not found. So after, I can only say that if I go beyond that list. If I'm going through the whole array and I'm not finding that value, that means it doesn't exist. So I can just need to return some kind of, it will return, if I'm not finding it, it will return -1. So -1 means I did not find it. But what if I put some number that is there? If I press the linear search, then okay, it finds it, and then it's going to return this position where it was found. Now this algorithm here works when it looks for an array that is sorted, but we would like to do the same, and they are without any sorting, without requiring the linear, the array to be sorted. Why this uses the sorting? Because look, if I put 5 and started linear search, you see immediately it just stop here, look here, and then because it's sorted, if it should be somewhere, it should be before the 18. So if I reach 18 and I'm looking for the number 5, knowing that all numbers after 18 are going to be greater than 18, I don't need to keep going and check. But this is because the array is sorted. But what if the array was not sorted? I will still have to go through all the elements one by one. So I would like to do something. I would like to do this kind of searching, linear search, by just creating a method that I'm going to call linear search. So I'm going to make it private, static, because I'd like to call it from the main. Is it going to be void? No, I'm going to return an int. That int would be either it's -1 if I did not find the value that I'm looking for, or if I found the value that I'm looking for, I will return that index of that value. So I'm going to call it linear search. Now in this linear search I need two things. I need the array. So I'm going to imagine that I'm going to have an array of ints, and then the value that I'm looking for, or the key. This is sometimes referred to as the key that I'm looking for to find. Now what I'm going to do is that I'm going to declare some kind of position, which is going to be my the result that I'm going to return. Either it's going to be the position of the key that I have found of the number that I'm looking for, or if I don't find anything, I'm going to return -1. So you know what? I'm going to initialize it with -1. And then what I'm going to do, I'm going to have a for loop that starts from the first index until the last index of that array. And then I'm going to go one by one, and I'm going to ask a question. If the array I is equal to my key, then I'm going to return position. Return the key. What should I return now? Now if I said that this is going to return, let me just show you something. There's something that I didn't plan for it, but I think it's kind of nice. Look at something that you can just mention to explain your code. You see, if you just do this, you know that this is called the block comment, right? But there's something nice if you just type 1 and then open 2. If you open 1, you press enter, it will close it for you. But if you open 1 and then you put 2 stars and press enter, it gives you this kind of a template that explains what this method is going to do. Now this linear search is going to search for a key linearly in an array. Linearly, well, in an array by checking each value one by one. Now the array this is the list. This is the list of values. I'm just putting this so you can understand what this is going to be at the end. This is the value that is searched, that is to be found in the array, and then this returns the position of the key in the array, or -1 if not found. Now this explains what this method is going to do. Now the advantage of this is the following. You see, if I put now my controls, oops, I wanted to do control space, and there's nothing. But if I'd like to use it, let's say, I'm going to use linear search. You see now linear search? Search for key in an array by checking each value one by one. This is what I wrote here, and you see the parameters. It tells you the list of values, I've forgotten S, key, the value that is to be found in the array, and it returns the position of the key in the array, or -1 if not found. So this is some kind of a documentation that I'm putting, so the one that are going to be using my method are going to be understanding what it does. And also for us, because we're working on it, so we know what this should be doing. So we initiated this because we wanted to understand what are we going to return. We're going to return two things: either the position of the key that we're looking for, or -1 if it was not found. Now if I'm here, I should return what? The position of the value that I'm looking for, and it is I. And if I'm not here, that means if I finished, if I never get inside here, that means this was never true, and then I'm going to return -1. So I don't need this one here. But I personally prefer to not use this method. I prefer not to return things. I will return only at the end. And then what I'm going to do is that if this is found, if I find it, I just put this I into this variable position, and if I don't find it, that means this will never going to be true, so the position will always be -1, and then I'm going to return -1. So if this is true, -1 is going to be replaced with the I, the position of the value that I'm looking for. If this is never true, I will never get inside, and then position will stay as -1. Well, I did not initialize the array because I will do that here, but I'm going to in a few. Now, it just assumes that you give me an array, I'm going just to look inside that array if this value exists in it. Now, I'm going to do something else. If I leave it like this, this is not optimized. Because what if the array is like 100 elements? And then the value that I'm looking for is the first one. After I found the first one, should I keep looking? I should stop the loop. So I'm going to break. As soon as I found the position, I don't need to keep looking. Okay, that's it, you can stop. And that's what I'm doing. Now, how to put those things? I'm just going to, let's say I'm going to initialize the array. Now, my array, array is going to be new int of, I don't know, what's the size? You know what, this is just giving me an idea. I just would like to have the size of the array to be random. I don't want it to be always 10 or 5 or 100. I just would like it to be randomly between, I don't know, these different numbers of, what is that? Okay, between different, let's say I want it to be between 10 and 20, so it can be any random thing. So how to do that? I need to use this random variable. I'm going to use this new random because I'd like to just use it many times, just also to put the values inside of the array. I want it to be random, so I'm going to put it as random as well. Now this random, I would like the number to be this max, this size, let's say the size of my array. I want it to be between 10 and 20. How can I do that? Now this, if I do rand dot next int and I specify here the bound is like if this returns a pseudo random uniformly distributed int value between 0, which is included, and the specified value, which is excluded. This is the specified value, which means if I use, remember we used this next int in our find the hidden number. When we used 100, it starts from 0 until 99. 100 is not included. Now if I put 10, now I start from 0 to 9. What if I want it to be from 1 to 10? Well, I just add 1. The random number is going to be from 0 to 9, let's say 5, then it's going to be 6. But what if it's 0? Can I have a size of 0? No. It will be, I'm always adding 1. So whatever this is going to be the randomly between 0 and 9, if you give me 0, I'll make it 1. If you give me 2, I'll make it 3. If you give me 5, I'll give me 6. If you give me 9, I'll make it 10. So this is going to be a random number between 1 and 10 included.
But the element did not change, right?
I'm not talking about the elements inside, just the size now.
The name of others?
The name of?
Index.
Yeah, I mean, no, the maximum index is something else. The number of elements. How many boxes I have in that array? It will be, well, it depends. I don't know. This is going to be random. Let me just, before I do this, I just would like to show you what is going to be the size by using this random. Okay, let's run this. And now the size is 4. Let's run it again. That's 10. Again, 10. Again, again, again. So it's going to be a random every time. But it's always going to be between 1 and 10. That's the maximum I can get. Okay? Now what if I want it between 10 and 11? Sorry, 10 and 20. Plus 10. So this plus 10, which means if I add 11, now what is going to happen is that it's going to always be between, is it 10 now? Or is it between 11 and 20? So it's between 11 and 20. If I want it between 10 and 20, well, fine. I don't care. This is fair enough for us. I don't want to spend too much time. But as you can see, this is going to give us every time a number that is between 11 and 20. Okay, that's the maximum that we can get. Okay, so this is just going to give me this, and then once I have the size, let's just leave it like this, and then I'm going to make the size here.
Let's start with the 10.
What do you mean it starts with 10?
Size.
The size? Yes, it starts with 11 actually. The minimum size is 11 because this is going to be from 0 to 9. No, I'm sorry. This is 9 plus 11. That means 10. Yes, it starts from 10 to 10 to 20. So the minimum possible here, this is going to give me a number randomly between 0 and 9. So the minimum is 0. What if it gives me 0? 0 plus 11. So it doesn't start from 10, it starts from 11, the minimum. But if I put this, then the maximum is going to be 19. So anyway, doesn't matter. Let's make it this to go the maximum to be 20, and that's it. Now that I have my array, I need to put values inside that array. So a for loop array.length, and then array I is going to be equal to if I need to put the value, I can ask the user to give me the values. But because we don't want to type a lot of values, I just would like to have random numbers given to me as values. So I'm just going to use the same thing. rnd.nextInt. But what's the size? How many values that are between what and what? I'm going to put between 100 and just like random numbers between 0 and 99. That's fine. And these are going to be put inside that array. And then at the end, you know what? I'm going just to display the array. So array of I, so I can display the array by putting something like this, and at the end just go back to the line. So now if I run this thing, what is going to happen just gives me the size is 17 and I have 17 numbers randomly between 0 and 99. I'll run again, it's 15 between this and that. I run again, it's now 19 between all these random numbers, and they're not sorted. So now I have just prepared something that is going to initialize a random size array between 11 and 20, and then with random numbers. Now I'm going to ask the user to give me, okay, search for a number, just for fun. I can also make the number that I'm looking for random, but let's just give some key b equal new scanner. So I'm just going to system.in, and I'm going to ask the user, please give me a number. So this is the array now. Please enter a number to find in the array. And then I'm going to declare this is the number that I'm looking for, keyb.nextInt. And then what I'm going to do is that I'm going to call this linear search. So now that I'm going to call the linear search, this linear search is going to give me the result of that, or the position. It's going to return a position, right? So I'm going to turn the position to be this linear search based on the array, and then not the size, but the number that the user gave me. So I'm going to give it the array that was initialized here as the first argument. The second argument is going to be the number that is given to us by the user, which is going to be our key. And then it's going to do its work. If it finds the number, it's going to return the position of that number. If it doesn't, then it will return -1. And then, based on this position, I'm just going to say if the position is -1, that means the number was not found in the list. And else, I'm going to say the number was found at position, and then I'm going to display the position. So this method here is just going to look for the values one by one, look for the key or the value one by one until it finds it. If it doesn't, then it's going to return -1. Now let's run this thing. So we have the size is 12, these are the values, and what you would like to look for. If you put 5 doesn't exist, so it's going to tell me the number was not found in the list. Now let's run it again with the number that exists. Let's say 12. The number is found at position 7. 0, 1, 2, 3, 4, 5, 6, 7. And this is the linear search. Linear search means just That's from the beginning until the end, and try to look for something to find it. Yes. Can I go up? Yes, all right. Here, yes. Yes, that's what we send as an argument, yes. Now, I just would like to make sure that to avoid confusion, this is different from, it doesn't have to be the same name. I'm just using the same name, but this is known here as A. I'm just working with this A, and A is the list of values, or maybe here, just going to call it lists. And then, notice that if I change it here, it's also changed in the documentation. This is like the Java documentation, that if now I'm using this with control space, it's just going to show me, now this is showing list, etc., with the list being the list of values. Yes?
If you delete static.
If I delete static from this method, yes, what is going to happen?
Yes.
Okay, what is going to happen if I delete the static from this method? Yes. I will not be able to call the method because I can't. But what if I want to keep it like this and still call it? I need to create an object. From which class? From the class that this method is in. Now this linear search is in this method called week 6 searching. So if I don't want to put this static here, what I have to do is create an object from this the class itself, and then I can have access to the method. So either I just put it static and that's it, or if I don't want to make it static, then I have to create an object so I can use it. Let's put 3. So 3 was found at position 3. 0, 1, 2, 3. Is that okay? So I'm not interested into leaving it as like that. It makes more sense at this time to just leave it as static. So that's what I'm going to do. Because if it's not static, you cannot call it from a static method, the main. The main is a static method. If you call another method, it has to be static. Is that okay? Okay, I'd like you to do this. So, before going to the next type of search, which is the bubble search, which is kind of more interesting and more, efficient. Why is it more efficient? Because let's face it, what if our array is kind of long? We have, let's say, we're using only from 1 to 10, and then what if it's not? If it's 100 and plus? Now, if it's going to be a long array, now, for example, if I'm looking for a value that is going to be this last one, I'm going to go one by one until the last element. There might be a better way to do that, and that's our next step, the bubble sort that we're going to be, the binary search that we're going to be looking at. Yes?
If there was another number 76, will take the first one it finds that send us this position?
Yes, that's a good question. Yes. Now that's a good comment. Now this algorithm here, this code here, stops as soon as it finds the first number that was given to us. Which means if I have many of these, let's say look at here, the 7. There are 2 of them, or maybe more. There's another 7 here, another 7 here. So now if I'm looking for 7, which one is going to be given to me? Because of this code, it just looks for the first one. As soon as it finds one, it just stops. So if there's another one, okay, fine, I don't care about it. I'm just looking for the first 7 that I found. So that's why if I press here, it's just going to give me position 3. But if I don't want to have the first one, I would like to have the last one, then I remove the break. Remove the break means even if I find it, it keeps looking and it's going to find the position of the last one. Now try to find a number that is going to be repeated. Which one? Number 8. How many times is it repeated? Once.
3 times. There's one of the first line.
This is 1 again,
In the last line.
and this is the 1. Oh, there's 2 in here. Okay, there are 2 here. All right, so let's find out 8. Now this one is going to give us the last one. So it's 101, and then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means this is 90, this is 89. So now it finds the last element that is the same. But for us, we just need to find the first one. We don't need to go for the last one. So anyways, what I want you to do is to